Okay, let's do this fairly simple parallel circuit. 3 resistors in parallel, 10K, 27K, and 20K. So 10K, K means 1,000, so 10,000, 27,000, and 20,000. So the first thing we want to do is determine what our resistance is in the circuit. So our total resistance, so our RT, will be equal to 1 over the resistance of 1 plus 1 over the resistance of 2 plus 1 over the resistance of 3. The total resistance in a parallel circuit should always equal less than the smallest resistor. So whatever our total resistance is, it's going to be less than this 10K resistor here. So you're going to use your calculator, your scientific calculator. You're going to look for this button, 1 over X. So you can use that button, or you can use this other button, X to -1. And basically all it's doing is it's putting it over 1. So entering it into the calculator, so R1 would be 10K, which is 10,000. So I'd enter 10,000 and then hit the X over -1 button and then add in the next one. R2 is 27,000. Then hit that button there. And then add in R3, which is 20,000. Hit that button again, X -1 equals. Now you got to hit that X -1 again. And now you're going to come to a value. The value you should have come to is 5,346 ohms. So that seems right, 5,346. We said it was going to be less than the smallest. So the smallest is 10K, so 5,346. And we're just going to put that in to milliamp form. So we're just going to 1, 2, 3 decimal places to the left. So I have 5.346, kilo ohms. 5.346 kilo ohms. 5.346. Okay, now let's do the current. The total current, according to our Ohm's law triangles over here, our total current is going to be our voltage divided by our resistance. So my IT will be equal to my ET, my voltage total, divided by my resistance total. So I have a total voltage of 100 volts and a resistance of 5,346 ohms. Volts is base unit, ohms is base unit, so you have to use ohms, not kilo ohms, or you're going to come to a different value. Okay, so if you do that, you should come out to 18.7 milliamps. 18.7 milliamps. Now, looking at a base unit 1, 2, 3 would be equal to 0.0187 amps. So a fairly small amount. So we're going to use the 18.7 milliamps. And according to electron current flow, electrons move from negative to positive. So that's how we're going to mark out our current paths here. So the current's going to split at those divisions and then, go through the various loads and then come home again. So we know we have a total of 18.7 milliamps that's in this circuit. So we know that this value here, right here, must be 18.7 milliamps. And then some of it's going to split over here. So we need to figure out what our voltage is here before we can determine what our current divisions are. So we have a voltage of 100 volts. So this point here to this point over here, we have a current of 100 volts. A voltage of 100 volts. And in a parallel circuit, the voltage remains the same. That's 100 volts there as well. So we've got 100 volts there, and it remains the same throughout the circuit. Okay, and then over here, 100 volts. Okay, so now we can get our individual amperages on these. So my amperage, so we're just going to use Ohm's law, my amperage at 1 must equal my voltage at 1 over my resistance of 1. So my voltage at 1 is 100 volts, and my resistance is 10,000. Don't put it in your calculator as 10K because you're going to be off. All right, so 100 volts and 10,000 ohms resistance is going to give me 10 milliamps of current through this division. So 10 milliamps right there. Now we said we started with 18.7 and 10 of that 18.7 went there, so it must mean that I have the balance, which is 8.7, or going through there. So then this divides. Now, because these two resistors are different values of resistance, it's not going to divide equally. So let's determine what our amperage at resistor 2 is. Amperage at resistor 2 equals the voltage at resistor 2 divided by the resistance of resistor 2. So 100 volts divided by 27,000 ohms. It's going to give me a total of 3.703 milliamps. 3.7 milliamps. Okay. We said we had 8.7 here, and 3.7 went down there, so that means we have a balance going through this one, which is 5 milliamps. You can check that. 100 volts divided by 20,000, 100 divided by 20,000 is 5 milliamps. Okay, so now we can get our power in the circuit. So let's start with our total power. All right, our total power in the circuit is going to be, power total is equal to my amperage, my voltage total times my amperage total. So 100 times 18.7 milliamps. So we're going to write that in base unit, 0.0187 amps is going to give me 1.87 watts. So my total power is 1.87 watts. And power at resistor 1. So let's take a look at P1 here. So P1 would be equal to E1 times I1. So we've got 100 volts divided by my amperage of 10 milliamps is going to give me 1 watt. So we have 1.87 watts in the circuit total, and we know that resistor 1 has just dissipated 1 watt, so we know that we must have a 0.87 dissipation between the other two resistors. So let's take a look at that. So let's see, power resistor 2 equals the voltage at 2 times the amperage at 2, and the voltage at 2 is 100 volts, and the amperage at 2 is 3.7 milliamps. 3.7 milliamps, which is really 0.0037. So you should come out with a value of 0.37 watts. So you got 1 watt there, 0.37 there, so it's 1.37, and we have a total of 1.87. So the last amount of wattage at this resistor must be 0.5 of a watt. And you can check that. Power at 3 equals the voltage at 3 times the amperage at 3. And so 100 volts times amperage at 3, 0.005 equals 5 watts. So let's just take a look at what's going on. We got the smallest resistor here, 10 kilo ohm. The smallest resistor is allowing the most amount of current to pass. The largest resistor is allowing the least amount of current to pass here. So the smaller the resistor, the more the current. The larger the resistor, the less the current. So that makes sense. Hope that helps.